Hi everybody. Today we are going to talk about ways of separation. There are a lot of informations in this concept, but I tried as much as possible in order to reduce the information and explain briefly. So let's talk about their categories, their types in the universe. Let's remember that we cannot separate two substances that have been chemically bonded together without occurring another chemical reaction, which is really difficult, nearly impossible. So let's say we cannot separate the substances existing and involving in a compound. And why? Because the chemical bonds on those substances have been chemically bonded together. So in order to separate them, another chemical reaction has to occur, which is nearly impossible. Therefore, we separate mixtures instead of compounds. There are a few ways in order to separate the substances existing in a mixture. For example, filtration, centrifuging, decanting, crystallization, simple and fractional distillation, evaporation, which is not a method, it's a part of crystallization, chromatography, and solvent extraction. So, at the first, let's talk about one of the most crucial and important methods in the ways of separation, which is called crystallization. This method is being used when you want to collect and exploit the solid particles from a mixture of a liquid and a solid. And also the process of condensation or evaporation, or the other ways, might be used during this process. In crystallization, we are supposed to add as much as solid particles which would be equal to the maximum quantity of the solid particles as it can be dissolved in the solvent. And this means that, for example, we have a mixture of salt and water. As you know, salt is soluble in the water. So, and if we add a lot of salt particles, so after its optimum quantity, it cannot be no more dissolved. So, and that maximum point, that optimum point, is called the saturated solution, which we are going to add solid particles as much as possible, but it also can be dissolved in the solvent. And also, if you add one more solid particle, it cannot be no more dissolved, which is called saturated solution. As you can see in the picture, and finally by using the process of evaporation or other ways, for example condensation, we remove the solvent and the solute is going to remain on the beaker. Now the second method, called filtration. Filtration can only occur when the substances in the mixture are not soluble within each other. Because if they were going to be soluble, so all the substances in the mixture, they were going to pass the filter paper because they are soluble with the solvent. So by evaporation, we are capable enough to separate them. The solid particles are going to be completely separated from the liquid. As you can see, after placing the filter paper on the beaker and pouring the mixture in the beaker, we can realize that the solid particles remained in the beaker, or let's say on the filter paper, and the liquid particles have completely passed through the filter paper. There is a tip here. Let's remember it all the times, that the substance which remains on the filter paper, which is all the times the solute, the solid particle, is called the residue. And the substance which passes the filter paper and will be placed in the beaker is called the filtrate, which is going to remain in the beaker. There is another tip that we have to know all the times, is that the filter paper is specific, might be different according to the mixture in the experiment. That means those gaps, those tiny gaps in the filter paper might be different while the mixture will be changed. Now let's talk about centrifuging. It's really easy. We are using centrifuging, the method of centrifuging, when those tiny particles have spread out. Those tiny solid particles have spread out throughout the liquid particles. And we cannot separate them only by using decanting, for example. And also they are remaining in suspension. That means don't make it to come to your mind that they are soluble. That's why the tiny particles have spread out throughout the liquid particles. No, that's incorrect. They remain in suspension. They are not soluble. But the solid particles are that much tiny, which they are going to spread out throughout the liquid particles, which would be a little bit hard in order to separate them easily. An example, separating the blood cells from blood plasma, which is really popular. Example for this method. This way, involves the suspension being spun around very fast in the centrifuge so that the solid particles flung to the bottom of the tube since it's more denser. So this method is also according to the gravity. So the ones in which, in this case, in this example, the blood cells, because they are more denser and it's a really thick liquid and they are much more denser, so they will flung out to the bottom of the tube since it's more denser. As you can see, after the suspension being spun around very fast, the denser substance gets flung to the bottom of the tube because of the gravity, as I said. And the blood plasma, that means the less dense liquid, in this case, will be placed at the top of the tube, and a boundary of separation will be produced. In this case, after pouring the tube on a beaker, only the blood plasma will be separated, since a boundary of separation has been produced between the blood plasma and the blood cells. And because the blood cells are a thick liquid and they flunked out to the bottom of the tube, so they are not going to be poured out. Only the blood plasma is going to be poured on the beaker, in the beaker. So here there is a tip. Let's remember that usually the method of centrifuging is being used to separate very tiny solid particles, which are spread out through the particles. That means they are that much tiny that they can pass through the filter paper. And that's why we are using the method of centrifuging. Remember this all the times. And now, one of the easiest methods is called decanting. Decanting is a method which does not need any action to take place. Remember this all the times. Since the solid particles are usually enough large that if you place the mixture in stationary, that means there's not going to be any movement for that specific beaker that we place the mixture in it. The solid particles will be automatically separated from the liquid particles, which is exactly the opposite of the centrifuging, because in the centrifuging, usually the solid particles are really tiny, which they are going to spread out to the liquid particles. But in this case, the solid particles are enough large that they are going to be separated automatically when they are being placed at stationary. Therefore, they will flung into the bottom of the beaker, as you can see in the picture. Look, if you are going to let the tube in stationary, as you can see, the solid particles will flung into the bottom of the beaker, which is really an easy method. And as you can see in the right side, it's exactly the same. As you can see in the mixture, two substances have been chemically bonded together. I think in this case is the soil and the water. And after a couple of time, the majority of the soils will flung into the bottom of the beaker. And waiting a few hours or days, we can see the clear water without particles of soil. So as you can see, only by putting the beaker at stationary, the two substances or more, the two substances in this case have been completely separated from each other. Fractional and simple distillation, which the majority of the students have a lot of problems in this case. Fractional distillation, what is it? This method is being used when, listen to this, more than two mixtures or compounds are going to be separated within each other according to their different boiling points. And in simple distillation, this method is being used when only two mixtures or compounds are going to be separated according to their boiling points. So the only simple difference between these two distillations is that in fractional one, that means in the left one, in the left side, in the fractional distillation, there are more than two mixtures or compounds that are going to be separated according to their boiling points. But in simple distillation, there are only two mixtures or there are only two compounds that are going to be completely separated according to their boiling points. There is a tip in both of them, that the one that has a lower boiling point will evaporate the first. For example, in the mixture of water and ethanol, they are soluble in each other. And while the boiling point of ethanol is 78 degrees and the boiling point of water is 100. So since the boiling point of ethanol is less than the water, so it will evaporate the first. And finally, by using a condenser, you can easily convert it into a liquid again, the one that you have evaporated it a few moments ago. And now, one of the most crucial methods for separation is called chromatography. A technique called chromatography is widely used to separate these materials so that they can be identified. The process happens when you place the mixture on the baseline. Baseline it's only a line which has been determined near to the bottom of the paper. And by using a solvent, usually water or ethanol, the substances existing in the mixture, which are soluble in each other, in that specific substance will move up with the solvent. The ones that are soluble, don't forget. The ones that are soluble, they will move up with the solvent in different rates until it reaches to the top of the paper. However, there might be some substances that are not soluble in that specific solvent. So they remain on the baseline and they are not going to be in a phase. They are not going to move. There is not going to be any movement which is going to occur. There is a tip here. By using a locating agent, you can see the substances occurring in the mixture that are colorless. That means there might be some substances existing and involving in the mixture which they do not have any color. They are colorless. So by using a locating agent, also you can identify the ones that are colorless. Remember that the plots move up with the solvent until a certain point. That means they will move up with the solvent in different rates and in different speeds. And the ones that are near to the solvent are more soluble. And this means that they spend more time in the mobile phase. And as you know, mobile phase this means that the substance can move freely in the solvents since they are very soluble in each other. As you can see in the picture, for example, there are three plots in different rates, and in this case, B is much more soluble than A and C. And why? Because B has spent more time in the mobile phase and can move more freely in this specific solvent. And at the end, solvent extraction. In this method, we are going to use a solvent which one of the substances existing in the mixture will be dissolved in that solvent. And by evaporating the solvent, because that substance has been dissolved in it, so will evaporate too. And the other substance or the other substances occurring and existing in the mixture will remain in the mixture. This means, for example, when we want to eliminate the chlorophyll, think about it. We want to eliminate the chlorophyll, those green pigments involving and existing in the leaf. Because the chlorophyll is soluble in ethanol, so we can add ethanol to the mixture. So the chlorophyll is going to be completely dissolved in the ethanol. So after evaporating the ethanol, the chlorophyll will be evaporated too, since they have been completely dissolved within each other. Finally, the chlorophyll will be completely eliminated. And the reason is that the chlorophyll was completely soluble in the ethanol. So when we added the ethanol in the mixture, the chlorophyll has been completely dissolved in the ethanol. And while evaporating the ethanol, the chlorophyll will be also evaporated. And at the end, the other substances will remain in the mixture without any chlorophyll. Thank you for your attention.